This screencast is looking at the ventilatory system, specifically looking at 2.1.3, which is to do with defining terms of lung volumes. This little diagram is used quite extensively to show our different lung volumes. The first one that we look at is called tidal volume. That's the normal amount that we breathe in and out per breath. So important there to remember that it's per breath. Tidal volume is normally measured in milliliters. Sometimes it will be expressed in liters, but normally expressed in milliliters. The next one we're going to have a look at is our inspiratory reserve volume. That's the amount that we could breathe in after a normal breath. So if you breathe in normally and now breathe in maximally, that is said to be your inspiratory reserve volume. So the amount that you would breathe in after a normal breath. Expiratory reserve volume is the amount that you can breathe out after normal expiration. So if you breathe out normally, now breathe the rest of the air out, that is your expiratory reserve volume. We don't need to worry about inspiratory capacity. The vital capacity, this is the maximum amount that you can breathe in and out per breath. So again, normally measured in milliliters. So as much as we can possibly breathe in and as much as we can possibly breathe out. Now the one there that is a little bit different is what we call our residual volume. If we breathed out all of the air from in our lungs would actually collapse. So we have to maintain some volume of air in our lungs to maintain the integrity of the lungs, the structure of them in a functional way. So that amount of air that's required to maintain the integrity of the lungs is known as the residual volume. The last one that we need to know is total lung capacity. So that's as much air as can possibly be fitted into our lungs. So total lung capacity equals vital capacity, so the maximum amount we can breathe in and out, plus our residual volume, so the amount of air that's required to maintain lung structure. So here, writing them out, tidal volume, the amount of air in and out per breath, normally measured in milliliters. Vital capacity is the maximum amount of air that we can breathe in and out per breath. Our inspiratory reserve volume is the volume of air that can be breathed in after our normal breath. Expiratory reserve volume is the volume of air breathed out after normal expiration. Our residual volume is the amount of air required in our lungs to maintain integrity of the lungs. Total lung capacity, well, that equals vital capacity plus residual volume. So it's the absolute maximum amount of air that we can fit into our lungs. A very important relationship for us to know is that ventilation here, which is the amount of air breathed in and out per minute, equals tidal volume, or average tidal volume, so the amount that we breathe in and out per breath, times our respiratory rate, or the amount that we breathe, as in the number of times we breathe per minute. So here's an example of 3 graphs. Here we have respiratory rate, tidal volume, and ventilation. So to work out our ventilation equals tidal volume times respiratory rate. So here's an example where tidal volume is actually measured in litres, or represented in litres, not millilitres. So ventilation equals tidal volume, which is around about 0.52 litres, times respiration rate, which is about 14.2. So when we multiply them together, we get approximately 7.38. And that would then be litres per minute.